Hello and welcome to this video going through the high demand questions for circuits, walking talking mock, looking at question 7 in this video. So the diagram shows the structure of a cable. The cable is part of an undersoil heating circuit inside a large greenhouse. We've got cable, can I check? Yep, so they're the copper bits there, insulation around them, copper braid then acts as the earth wire, insulation around the outside. Okay, so it's like it looks similar to a normal wire except for this braiding. That just means that's the earth wire instead. The cable is connected to the mains electricity supply through a residual current circuit breaker. If the cable is accidentally cut, the circuit breaker automatically switches the current off. Now, I'm not sure if this is an old question. I'm not sure if residual current circuit breakers are still part of the curriculum or not, actually. So they're known as RCCBs, and they are devices. They're like a fuse. They're circuit breakers. You find them on the front of power packs, things like that. You can reset them, which is really useful. What is the frequency of the mains electricity supply in the UK? Well, we do need to know that, and in the UK it runs at 50 Hertz. That means those electrons change direction 50 times every second. That's why mains electricity hums the way it hums. It hums at exactly 50 Hertz, as does pretty much everything that runs on electricity in the UK. So hairdryers spin at 50 times a second. Yeah, that's the noise of electricity in the UK. Whereas go to different countries and the frequency is different. What happens as the cable is cut to cause the circuit breaker to switch the circuit off? Okay, now key bit of information I'm missing there is how many marks it's worth. It's worth 2 marks, so 2 bullet points. As the cable is cut to cause the circuit breaker to switch the circuit off. Okay, so it's got an RCCB. So what happens is that current flows to earth as soon as you cut the circuit. So current will flow to as soon as you cut the wire. The safety device is the earth there. You can see that earth flows to earth through the copper braid, that's called. Okay, because it's not an earth wire. Well, you could say earth wire, it's fine. Current flows to the earth through the copper braid, and the RCCB compares the live wire and neutral wire. And normally, because the live wire, you can imagine it's a normal, if it's a basic circuit, the live wire carries the energy, carries the current to the device. The neutral wire carries the current away. They should always have the same amount of current. So the RCCB compares the live wire and neutral wire currents, and they should be the same. And in this case they won't, they will be different. So it switches current off. And that's what it does. It breaks the circuit. Okay, because those 2 wires are different. A circuit can also be switched off by the action of a fuse. Give one advantage of using a circuit breaker to switch off a circuit rather than the fuse. Oh, well, the main one there is circuit breakers can be reset. If we had only fuses in all our power packs, then every time we did any experiment with students, we'd end up having to change all the fuses. The 230 volt mains electricity supply causes a current of 11 amps, so it's 230 volts, to flow through the cable. Calculate the amount of charge, okay, so I'm looking for charge, that flows through the cable when the cable is switched on for 2 hours, and give the unit. So I can tell straight away this is an old style question, because these days with the new papers they wouldn't give me that 230 volts, because I don't actually have to use that at all. I'm looking for the amount of charge, and I know that charge is Q is equal to I times T. So I'm just going to pop a line down here, write down what I know. So I know that I is 11 amps, don't need to convert that. T is equal to 2 hours, which is 2 times 60 minutes. And I'm going to times it by 60 again to get it into seconds. So I'm then going to substitute it into here, so I get 11 times 2 times 60 times 60 equals, what's my calculator say, equals 11 times 2 times 60 times 60 equals 79,200 coulombs. So 79,200 coulombs. I'm just going to check that again. So I've got 11 amps, 11, that seems like a high number, 11 times 2 times 60 times 60 equals 79,200. Yeah. Calculate the energy transferred from the cable to the soil in 2 hours. Okay, well I know that energy is power times time, and I know that power is VI times time. So I know that formula there. Let's just have a quick look over here. So let me just, I'm just going to put a line there, just so I've got room to put this. So I'm going to do, I know V equals 230 volts. I know I is equal to 11 amps, and I know that T is equal to, what was T equal to? 2 times 60, oops, 2 times 60 times 60, 7,200 seconds. So I know that E is equal to 230 times 11 times 7200 equals 18,216,000, 18,216,000 joules. Oh, sorry, I don't have that on the screen. Oops. Okay, hopefully that makes sense. You see the way I've laid it out, deliberately put these lines in to try and make it clear what I've done and why I've done it. So I always remember the energy is power times time formula. Some people might just go straight to energy equals VIT, that's fine. The heating circuit includes a thermistor. The thermistor is buried in the soil. Let me just remember what a thermistor is. It's a type of resistor. It's a thermal dependent resistor. The thermistor is buried in the soil and acts as a thermostat to control the increase in the temperature of the soil. Okay? Describe how an increase in the temperature of the soil affects the thermistor. It's worth 2 marks, so 1, 2 bullets. How does an increase in the temperature of the soil affect the thermistor? Well, I've got to describe it, so I don't need to explain why. What's going to happen? First of all, as soil temperature increases, thermistor temperature increases. This thing's buried in the soil. So as the soil gets hot, it gets hot. Okay, so what happens then to the thermistor? Well, most electrical objects, when they are given more energy, so if I start off at 0 here, if they're given energy of any sort, thermal or light or anything else, then the ions inside them vibrate more quickly and resistance for most things increases. So as they gain energy, the resistance goes up. So with a piece of wire, for instance, the hotter it gets, the greater its resistance. The only two objects, only two types of resistors that don't behave like that are thermistors, which are the opposite, and light dependent resistors as well. Both of these, as they gain energy, their resistance actually goes down. So as they gain energy, their resistance goes down. So as its energy store increases, its resistance goes down. So increases the thermistor temperature, which means the thermistor resistance decreases. You don't need to say why, because it's a described question. You don't in fact, you don't need to know why. That's A-level physics territory. Right, hope that was helpful. Take care. Bye.